Go ahead and read that real quick. So this is just a comic, but I think it gets the rub of portion. So when you finally present or finally publish your paper, that's the moment that gets all the glory. But before that, there's been years and years of work behind it. And that's the long, arduous process in which you'll find yourself doing really mundane tasks over and over and over again. And that's the part that I think I can offer some help with. Some ways to automate that so that all that time spent working towards your presentation or paper goes much more smoothly, and hopefully also improves the quality of that research as well. So talking about automation, let me give you this scenario. So it's really easy to get started on a task. You start, say, putting a new data result into an Excel row. You have to change this and that and get it perfect. And then you do the next one, and then the third one, and the fourth one. And pretty soon, it's been an hour, you haven't come up for error, and your wrist kind of hurt a little bit. And you're like, oh gosh, what have I been doing? Well, I want you guys to consider forcing yourself to stop after you spend about a minute or two doing something like that. And ask yourself, I've been doing these iterations. Is there a way to automate this task? Or do I need to go back and just finish it and be done? Now, the catch-22 here is that if you have to first learn how to automate the task in order to then implement it and run it, the answer is always going to be no, because, gosh, you have a task to do. You wouldn't be doing it if it wasn't due pretty soon, unless you're really good at doing things ahead of time, which I am not. So the first step is to figure out what sorts of things you're probably going to be having to automate in the short term, and actually learning that up front so that you'll be ready. And so when you get to this question and ask yourself whether or not you should automate this task, you can say, well, I already know how to do it. Let me think here. Oh, it'll only take a few minutes to put it together. Put it together, and then hit a button, and then it'll be done like that, instead of sitting there and getting carpal tunnel. So I would be remiss if I came here and didn't at least present some research to you. So I wanted to show you a study from the United Kingdom that they surveyed a group of researchers recently, and almost all of them are using some sort of software to enhance their research. And not only that, but over half of them are writing their own, which is huge, because that's not something you would normally associate with your research. So I'm trying to get the point across that I'm not trying to sell you some snake oil here. This isn't something coming out of left field. This is something that's becoming a standard operating procedure in the entire research community, and something worth educating yourself on. So I'm going to go through the different stages of the research process, and I'm going to try to tell you how to automate each of those steps in different ways. We're going to start with collecting the data. So it wasn't all that long ago that the internet was some sort of weird thing that you logged on to after 5 minutes, and oh look, I got an email, and it was this huge deal. Well, that was maybe 20 years ago. Now we all have, or most of us have, smartphones in our pockets. We get emails, texts, everything right there. The internet's always with us, 24/7, 365. There are people that even sell vacation packages to get away from civilization so that you can't be followed around and tracked on your cell phone and get a little bit of a break. But this modern situation has led to some pretty interesting opportunities. For example, there's a service called Turk that has a bunch of people that are sitting there waiting to take on tasks. So you could say, hey, I'm going to offer $5 for filling out this form, trying this out, and you can use those people
Hey Richardson, we can hear you. Sorry. Thanks.
And anyway, you can, and this group of people is a much more diverse group of people than your average set of undergrads that you that saw a flyer and came down because they were desperately in hopes of getting $5 really quick. And so if those subjects were great for your research, they're there at an instant. And you can get your feedback right away. And even if those subjects don't match what you need to be doing, they make great test subjects. So say you've got your wonderful group of people you've been selecting all this time, and you've never actually gone through your test procedure with anyone before, any real people. Well, when you actually do it, you might screw it up. Or you might find that, hey, they don't really understand this part or that part. Here's a resource where you can throw it out to them. They're real people. They'll let you know if it doesn't make sense. So it's great for just vetting your tasks. And then speaking of having the internet in our pockets, Apple's made it really easy with a product called ResearchKit to develop research collecting applications. You don't have to know how to do a whole lot of programming. And what it allows you to do is get an app out there to all of your subjects, and instead of them coming into the lab for a very artificial session, you could do very interesting things like, say you wanted to get natural language samples when the kid's most talkative and comfortable, say at meal times or something. You could have the parent record them right there at breakfast every day, and when they're done recording, the data goes straight to you, not to Apple, and you've got your language sample that you can then analyze, all without having to bring them in, interrupting the work schedule, convincing parents to please come back again, all that.
So just,
Yeah.
You're okay, wait.
Oh yeah.
Okay, I just, so I have a couple of questions on these, just on, I know that Untitled Turk I've heard a decent amount about, and you can pay a lot less than $5, right? Don't some people do it for like almost nothing? They'll do like $1 or something, or 50 cents. So you can get tons of data.
Successful with $1.50 for an hour.
So do you set up an account and it just pulls money from there as these people sign in? I mean, I think I've kind of, is that how it works? You just.
So you
I mean, I've actually, so I've been using it. And
Okay,
it's,
sorry,
it's
this
awesome.
may derail your,
No,
I
it's
didn't mean
great.
to do that, I
It's
just
great.
wanted to kind of.
Yeah, it's
know a
great.
little
So
bit more.
you set up like an Amazon account. There's actually, they now, I talk to people in accounting at UTV. So UTV's accounting and treasury people have a system set up where you go to them and you say, I want to deposit this much into my account, and then they go through the EIN. So it's all through like the university system.
Nice.
You don't have to pay taxes on it or anything like that. And then they'll take it from your P card or from your university funding account, deposit to Amazon, and then when someone logs in, it just takes from that pool of money, and then when you run out, you can refill it, whatever. And it, I mean, 24/7, it's been pretty reliable. They've even done some cognitive tasks, so like to some extent, things like reaction time can even be done. I mean, granted, there's a huge variability in terms of how fast what machine people are using, but you still get the same ordinal data, and you can even do some looking stuff with the camera. So it's been very successful. I've got a handful of stuff, and I'm more than happy to share and send on. Because I started using that last year.
And then
It's great. It's fantastic.
I'm assuming they have ways to work through your IRB to do that as well, right?
Yeah.
To collect data and-
Actually, oh well. So yeah, you would have to get IRB approval,
Yeah.
but at least there's no monies with that one. You don't have to worry about
Okay.
that.
So I'm wondering if it's sent directly to you. I mean, I don't know, UTD seems to be crazy about how things are sent to you and in what way when it comes to subject data. So, okay, cool.
Those are the NEPA standards to get around the IRB for
Okay.
But these are great.
And that actually, real quick before you move on, that's actually the coolest thing you guys can do is once you figure out something like that, like you've actually used Mechanical Turk, learning from each other is going to be way more incredibly valuable than anything I can tell you, because that's going to be how you actually get things done. And in this presentation, I'm hoping just to give you the gram an idea of what to pursue. And then from there, I'm hoping you could share and get really cool things done. So it's much easier typically to deal with things that are already digitized and on your computer, but you're not limited to that in any way. Some of your lab equipment might already be set up to work with a product called LabVIEW, where you can run this program and it'll collect all the data from the sensors. If it's not, there's a sort of an explosion in microcontrollers, they're called these days. You might have heard of maker movements. There's people making all sorts of interesting robots and everything else. Well, you can use those same tools too to connect to sensors, to connect to motors, and to automate some of your research. And it doesn't have to be something really complicated. You don't have to go out and buy anything. Something as simple as recording your instructions for all of your participants ahead of time and then playing them back at the beginning can have huge results, because you don't actually have to worry about forgetting something then. If you omit an instruction at the beginning of your verbal dialogue, you could throw off the results of your test and lose a valuable participant. But if instead it's already recorded, done, tested, there's no variance in the delivery, and you're good to go. One less thing to worry about. All right, and now I'm going to start talking about automating how you store your data. Go ahead and read that real quick. So your data is like the most important thing you have as a researcher, and you've spent years collecting it. Whatever you do, back it up. This is like the most important thing to do, and there's no excuse for not doing it. But the approach that I used to take, and I think many people still do, is you've been working on something for all day long. It's 3 a.m. You're like, I need to go to bed. All right, before I go to bed, I'm just going to save this to my backup drive or whatever else. And so you do this manual task at 3 a.m. unlimited brain power, and something's going to go wrong eventually. It's happened to me, and I'm sure it's happened to you. Lost papers, deleted the wrong thing. Don't let that happen to you. Use automation. If you're using OS 10 or Windows, anything newer than Windows 8 or OS 10.5, there's a built-in utility, either called File History or Time Machine, depending on your OS, that will do all this for you. You basically say, here are all the folders that I want to back up. Go ahead and do that to this drive, bada bing, bada boom. Just make sure you leave that drive connected and you're good. It'll take care of it for you. And we'll do something even more important, because backing up your data only does one thing. It gives you the current version of the file backed up. Now if you screw up, or you're like, oh, I shouldn't have removed that, I really need that information, it's lost forever. With these utilities and with some others, they also keep track of individual versions of your files, so that you're not hosed. You can go back and look through and say, oh, there's the missing snippet that I deleted. I can put it back in, which is also a very important thing you should have. Now, if you're operating in a collaborative environment, or you need to have more explicit control over what's backed up and where, consider using a version control system. These require a little bit of a learning curve, and they're definitely not for everyone. But if you're collaborating with others on the same document, there's nothing like it. It allows you to share a version control, do merges, keep track of the history together collaboratively as a team.
So I have another question.
Yeah.
So, can you, using Time Machine, which I have, but I keep all my files on Dropbox, which allows me to kind of share with other people too. Can you use Time Machine on Dropbox, or can it only be used on your hard drive, like on this stuff on your computer?
So Time Machine can work over on anything that's local. Okay. And so if you have a Dropbox folder and you tell Time Machine about it, then it'll still watch it. And it doesn't even need to know about Dropbox. And
it just sees it as part of it.
Yeah. Now they might fight. I've never actually tried it.
As long as they don't involve me in their
All right. I'm I'm going to start talking about how you actually physically store the data on your hard drive. But before I do, I need to talk a little bit about the form that we represent your data in. Some data is much better suited to a tabular form, especially when each item has its own context and you don't need anything beyond that. Something that I can use an example is your address book. If you look up someone in your address book, you don't really need to look anyone else up. You have everything there you need in order to find their address, give them a call, whatever you're trying to do to reach them. Now, if the data has connections between it, if each item needs a bit of context to have a richer meaning, think about representing your data in a relational form. Take, for example, a university. You've got a bunch of different faculty members. Each of those faculty members belongs to a particular department. Each department is responsible for a set of courses. Each of those courses is then taught by a member of the faculty. It can be possible to sort of contort that into a tabular form, but it's much more cleanly represented in a relational form. And there are some things you can do with it when it's in a relational form that I'll show you in a minute. So, first storage option, I'm sure the one that most of you are most familiar with, are spreadsheet programs like Microsoft Excel. They're very convenient, they're very widely used, and it's because they can represent most of your data without any loss or any compromise, because at the end of the day, a lot of your data will be tabular. But they have their limits. If you need to represent relational data, it's painful. It's possible, but it's really painful. Don't do it. Not in a spreadsheet. And if you need to have a lot of data in there, you'll start running into some problems. Now, there are some hard limits as to how much data you can put in a spreadsheet, but by and by, the rule of thumb is when it starts taking a couple minutes to load and your computer's kind of twitching while you're doing it, move on. Don't use a spreadsheet for that. You're sort of abusing the system. And then on your personal computer, if you don't have a Microsoft Office license, consider using a compatible free alternative like LibreOffice that's more or less gives you the basic functionality and compatibility with Excel, but it's free. All right, now let's talk about databases, which is probably something you're less familiar with. These can handle huge amounts of data, and they work well both with tabular data and relational data. But there is a catch. In order to talk to them, you kind of have to speak their language, which in most cases is the structured query language or SQL. Thankfully, there are a lot of free options out there for using a database. The one I would point you to is SQLite, because it's the simplest to deal with. Most of these databases are intended to be used by multiple users, and so they set up like a server on your computer. It's a mess to deal with. SQLite, as soon as you're the only one using it, it just operates on a single file. If you want to back it up or share it with someone, you just copy it in an email, you're done. And because that doesn't do justice to describing it, I'm going to do a quick demo for you. Yeah?
Just really quick, do you have like opinions on Microsoft Access versus FileMaker? Like, do you hate both of those?
I do have opinions.
Yes.
So Access and FileMaker are both good at what they do. They're both database programs, but there are two problems.
Mm-hmm.
One, they cost a lot of money, and while most of you have Excel licenses through the University of Texas, you don't actually have Access. That's not usually included, so you're kind of shelling out. And then with FileMaker 2, you have to pay for it. And then on top of that, you've got this thing you have to figure out and learn. Right. And you're kind of stuck. If you want to share it with someone, well, not only do they need to purchase it, but then they also have to learn it, which is a pretty high burden. So if you already know them, stick with them. They're great. But if you don't, the options I'm recommending are free, and you can easily share with others. But the compromise is Access and FileMaker both have very nice GUIs, so they feel gentler to start with. I'm encouraging you to join the dark side and jump over the curve a little bit. Okay. There we go. So earlier I created a completely fake data set, so try not to pay too much attention to the data, it's all made up. But I created a data set that simulates my rough guess at what a language sample would look like. And I did it for 200 simulated kids coming in for somewhere between 3 and 10 sessions, all within a relatively small period of time for each child. And I limited what words they could even possibly say. So this is very fake, but I wanted to share it with you and give you an idea of what you can do with something like not only the relational form of your data, but with something like SQLite. So I'm using a graphical program called SQLite Browser. There are, even though by default these things don't come with their own user interface, it's all on the command line. They do sometimes have things you can use, like this program, like SQLite Browser, that make it a little bit gentler to play with at first. So going through this a little bit, these are all of my different tables. Each table basically represents a bunch of data in tabular form, but also allows you to connect to other tables. So let me show you some of the data I've got here. So I've got two genders, male and female, no surprise there. This is my language samples table, which basically connects everything. It connects the words that are spoken to a particular session. Each of my sessions occurred on a particular date and involved a particular subject. These are each of my randomly generated subjects, all 200 of them. I even randomly generated the names. These are not, it's not taken from anything. And came up with I took the 100 most popular boy and girls names. So if you need fake data, I'm really good at it. And then this is my random set of words. So now here comes the magic. I'm now going to show you what you can do with this. And I normally would come at this and just start typing, but that's going to be too slow for this presentation. So I've got a bunch of SQL queries that I've written ahead of time to just give you a sample of what this can do. So this is going to answer the question, say I'm interested in what are the most popular words? What are these kids saying? What do they like to say? I can answer that and find out that the 5 most popular words that our kids are saying are year, these, her, out, and use. Now, sometimes that's good enough. Sometimes I want to know a little more, like, oh, well, what are the least popular? With a small change, I can find out that to, new, and, not, and back are the least popular. And on the left, that's the number of utterances across all sessions and all users. Now for my research though, say I'm interested in dichotomies between boys and girls, I can then start asking questions, well, what are the girls saying? So here are the 5 most popular words spoken by our girls. Year, what, will, her, and even. And if I wanted to change it to boys, not too hard. If I turn off caps lock. Something completely different. Then 1, 2, now, and these. And again, completely random, don't read anything to that. Just notice that it's different because I'm actually analyzing the difference between boys and girls in this case. And let's see here. Okay, and now say I'm interested in a particular subject. So I'm pulling up the session information for a girl named Summer Price. And I can see that over time, this is, I can actually graph this for you. So you can see that this is the number of utterances, the number of words she's saying in each of our sessions starting in 2012 and going through 2013. And it seems really big, but that's just because the scale starts at 315 or so. But analyzing one subject isn't quite as interesting as analyzing everyone. So let's see here. So this is the average number of words that anyone speaks. So you can have some context for that 315 low number. Like, well, most of the kids are saying somewhere on the order of 450 words. And maybe they're chattier at different times or different years. So let's see if that changes over time. Maybe these different batches of kids are watching Sesame Street more or less. So I can graph. Here I've got over time each year, the number of utterances. The bottom line is the min, the middle line is the average, and the top line is the max. And interestingly, even though it's random data, for some reason, towards the end, well, actually that makes sense because there's probably less data at the end. The variance is lowering, and you have everyone a bit closer to the average. So anyway, so the point I'm trying to make for all these examples is that the benefit to storing your data in a database and then accessing it this way, once you learn SQL, is that you can ask questions. You don't have to sort of have everything in mind, how you were going to construct your study. You can explore it. Go ahead.
Does it have data analysis tools? So could you run an ANOVA on any of this information? Or?
Not in SQLite.
Okay.
But that'll be the next part of the chain.
Oh, yeah, you did that. Sorry.
Oh, no, it's fine. Because so one of the trade-offs with using these really powerful tools is that they don't do everything for you. Think of these as sort of each link in a chain, and if you can put them together, that's when you can do some really amazing things. So there definitely is a way to connect this, to go from saying, all right, run this SQL query, get this data out, and then have another program do the analysis. But we'll do that in a bit. Okay. Now, talk about processing.
I was going to ask you about the results, right?
Paper generation. All right, so it may be a bit basic, but find and replace is actually one of the most handiest things that you'll encounter in terms of dealing with your data. And in its most basic form, take one word, replace it with the other. Still incredibly useful, but as with even the other forms, it's important to realize, okay, well, what else is going to change? Am I actually going to be switching out exactly what I want, or am I going to get some unintended consequences here? So it takes a bit of practice to the point where you get really comfortable and familiar with it, and you always kind of want to check through, but it can save you a ton of time. And for things like TEH space, there's not too many words that end in TEH, so you'll probably be okay. But I challenge you, once you become familiar with that style of doing find and replace, learn some of the other options that are a little more advanced. Some text editors have the ability to do basic pattern matching, and in this example, I've told it to find 3 sets of numbers separated by dashes. And using that, it's not going to get too much extra data depending on what's in my data set. In this case, I only have 2 numerical fields, so it will be fine. And I can use that to replace it with redacted so that I can get rid of all the social security numbers in my data and make my RD much happier, because then I won't be holding on to that information. But if you really want to go full bore on this, say finding and replacing is something you do a lot, it might be worth learning regular expression syntax. And you might enjoy the language aspects of it, but what it can do is it can basically match any pattern that you can come up with. And so you can do something a little more nuanced. Say in this data, I don't want to identify people by zip code, because for some reason that's too much information. So I need to step it back up a bit and just put the state in. I can specify specific ranges of zip codes and have that replaced with the state. So definitely something worth learning if you do that a lot. So I'm not going to waste your time trying to get you to use any of these tools because I'm sure you already use one of them for statistical analysis. But I do have a couple things to tell you about them that you might not know. First of all, if you're using SAS, MATLAB, or R, you have the ability to store all your commands in a file. So this is really useful. I think most people, when you open up one of these statistical analysis programs, you start typing in commands, you start doing your analysis, you explore a little bit, you figure out what you really want, and then you finally get the result. But 2 weeks later, oh shoot, I need to do this slightly different data set or a slightly different analysis, and you're doing it all over again from scratch. If you save your commands in a file and the whole process, then you can load it up with the slightly different data and just run it again, and it's done. And that can save you a lot of time and reduce errors, so that you're not forgetting, oh, I need to first normalize my data or whatever. And then the second thing to think about are alternatives to the tools you're already using. This is important to think about if, say, you want to run your analysis at home, or if you might no longer be associated with the University of Texas at Dallas in a year or two, you might be moving on to a different institution, and they might not have a license for the same program you're using. You don't want to lose access to all of the work you've been doing, all of the analysis that you've already run. And so in that case, consider looking into the open source alternatives for the programs you're already using. You'll notice at the bottom there's a program called S that I'm sure most of you have never even heard of. That's because R, which you have heard of, I'm sure, completely supplanted it in the 90s because it was a superior solution and it was open and free. However, you're probably less familiar with the other ones, and that's for a good reason. They are not nearly as easy to use as the ones you're paying for right now. But again, something worth looking into if you're worried about losing access to the licenses you have right now. All right, now I want to talk to you a little bit about putting some of these parts of automation together. This is a problem that is not unique to research, and one that the creators of the Unix operating system back in the 70s struggled with and came up with a pretty good idea. So what they did is they said, all right, we're going to create a bunch of little tiny programs that don't do a whole lot. They'll just do one thing, but they'll do it really well. And then we're going to figure out a way to combine them together. And they did that by just streams of text. So one program would read in a bit of text and spit out a slightly changed bit of text. And the next one would read it in, change it a little bit more. And combining those, you can do some really powerful, amazing things. And it turns out that even today, 40 years later, that's still kind of the basis for how scripting works. So no matter what operating system you're running, there are options for you to use that allow you to essentially create an assembly line of different automations. Most of these, unfortunately, this being something derived from the 70s, are all done on the command line and not that easy to use or learn. Still could be worth it, but there's one in particular I want to point out. For OS 10, there's a product called Automator that's very easy to use because everything's graphical. You just throw it together. And I'm going to give you a demo of that right now. So I've opened Automator. Oops. Oh, let me open a new one. All right, so I'm going to create a workflow. And let's say that I'm preparing my paper for publication, and I've got these really weirdly named images, and they're in the wrong format. My journal requires that they're in TIFF format, but they're in PNG right now, and there's a bunch of them, so I don't want to have to open them up, change everything, and then rename them. I just want to automate it. So I'm going to start out by asking myself for a bunch of different items from the Finder, which is the file explorer for OS 10. And then I'm going to right away change the type of the image of photos, change type of images. And it's going to prompt me, it's going to say, whoa, 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 if you change those, you're actually going to get rid of the original file. Do you want to add a step in your automation to make a copy first? And yes, that sounds like a great idea. So I'm going to first copy them to the desktop, and then I'm going to change their format. And because I'm really particular about how my things are named, goodness knows why, I'm then going to rename them. Right now, they've got all sorts of weird file name conventions. I want them to be all lowercase. This time, it prompts me again to copy them, but I've already made a copy, so I don't need to make another one. So I'm not going to do that. But I am going to say change case. I'm going to make the entire thing lowercase. And then, because I've got other images from my other papers, I want to make it clear that this is for a particular paper that I'm submitting. So I'm going to add another rename task here. Again, I don't need to make a copy. And then I'm going to say, all right, add some text at the beginning. And I want to say this is, again, not capitalized, my cool paper. And now I can run this. So it's going to ask me, all right, what do you want to grab? All right, these are all my images, so I'm going to select them all. And a quick tip on automation, there's usually shortcuts for selecting everything. On the Mac, it's Apple A. Saves you from clicking on everything. Once I choose that, it runs the automation. I'm basically done. All I have to do is check the output, make sure it makes sense. So here's my desktop, and you can see I've got a bunch of different TIFF files. They've all got lowercase names, and they all have my cool paper inserted before them. And now I'm happy. Now I can submit them to the journal. Now they're the way I want them.
Can you also change the resolution of images as well? Reduce the file.
Not with Automator, and that brings up a really good point. So Automator is sort of like a subset of all the possible programs you could possibly run if you were using the command line. But even then, there are a limited number of options for what you can do if you're relying on programs that everyone else has made. So switching then back to the presentation, the next step, if something doesn't exist that you need to complete your task, is probably the hardest thing that I'm going to describe to you today, but also the most rewarding, and that's learning how to program, how to use a general purpose programming language to do nearly anything. The power this gives you is hard to overstate, but it's also an investment. It's something that takes time to learn and can be frustrating at times in its own way. But if you're interested, I highly recommend you start out with learning the Python programming language. It's something already widely accepted in industry, and by industry in this case I mean the research industry. And it basically has everything in there that you'll need. And it's one of the easier ones to learn. Again, comparatively, but definitely a good place to start. All right, switching gears again, let's talk about sharing the results. So something that I think will apply to everyone here are dealing with references. So say you're working on a new paper, you're doing your research, you start looking through 10 articles, those articles have a bunch of different citations. Before you know it, you've read through 100 papers, and if you haven't been good about keeping notes, you've forgotten everything. So something that you can use to solve this problem is automated reference software. Something like Zotero, Mendeley, papers are in Note, some of which are free to download and use. They can do really cool things. They can have a plugin for your browser so that you're going to an article's site. There's a button there to import it. It does everything for you. And then let's just search through them, collect them, collate them, and then when you're ready to put them in a paper, you can export them and keep all their citation data intact, put it right into Word or whatever else you're using. And I also like to mention Google Scholar. I'm sure you guys already know about it, but you might not have seen there's a little site link at the bottom of each search result in Google Scholar. If you click on it, it already has the most common citation formats there for you to download directly, so you don't have to put it together yourself. and potentially get in trouble if you screw it up. All right, the biggest struggle that you can have, especially on a larger paper like a dissertation, is dealing with formatting. And the reason is, if you're using something like Microsoft Word, the formatting and the content both get intermingled, and they can fight. The way to solve that is something called LaTeX. It keeps everything separate. The formatting instructions are separate from the content. The trade-off is that you do have to learn the markup that LaTeX uses for the content. But when it comes time to format, there are typically templates that already exist that you tell LaTeX to use, and it does everything. It formats it, puts all your citations in there, uses the correct style for those, and then you can submit your thesis. Now, I say thesis particularly because this is going to be mostly useful for master's and PhD students here at UT Dallas. It's not going to be very useful if you're submitting to Ashford Journals, unfortunately, because they only allow you to submit in Microsoft Word format. And I don't know why, but that's their limitation. And there's no easy way to go between the two. So I'm sorry if you can't use LaTeX, but it really is awesome.
Does it translate to PDF?
It does. It definitely does PDF. Yeah.
Site journals use PDF.
And the first thing to do before even learning LaTeX, go to the journal that you're most interested in submitting to, figure out if they have a template for you to use, or if they use APA 6, there's already one there that works great, which is why it's a shame that Ashford Journals don't accept PDFs, because it already has a template for you. But even if you are limited to Microsoft Word, check out its citation manager. It does have one, and it can format your references for you and save you a little bit of time, which is better than nothing. Okay. Now, all of this stuff I've been talking about, as I mentioned before, it takes time to learn, but it can be useful to your colleagues. It can be very, very helpful for your colleagues if you put together some scripts, potentially even programs, share it with others, share it with your community. There are free websites like GitHub where you can post the code, but you can also use the university servers. Each of you is given, when you come to UT Dallas, your own web space if you set it up. Use that, use a lab website, and share your work. And it's especially helpful when it comes time to share it with the wider community, especially if you're in the public health area. You want to have a wider audience than just the research community. Use the web. If you learn HTML and JavaScript, you can even make an interactive site to display your data and interact with your users and really sell a message. And then get that message out through Twitter, Facebook, social media. Reference your website, they'll go to it. And you can have much more of an impact. All right, finally, this is a bit overwhelming. Where do you start? Where do you actually get help for this sort of thing? Oh, sorry. So undergrads may not be plentiful and available for you, and even if they are, they might not be much help. But it's great when they do. So in lieu of that, of course, use Google, use a search engine, just ask. Ask the question, get better at learning how to ask those questions in a way that Google will understand. And then if you see a link that pops up to Stack Overflow, it's a wonderful website. And it's probably one of the best curated sites of question and answer format data there is. Very heavily curated, very useful, very relevant. If you do want to learn specifics of a specific scripting language or Python, there's a collection of free books that you can go to online. And I've listed the link here, but I can give it to you after this. And then finally, there's a group called Software Carpentry who's made it their mission to help researchers learn how to program and to accelerate their research. It's volunteer-led. They do weekend workshops. I don't know if it's something that the UT Dallas community would be interested in, but if you think that you would be, please come talk to me after this. I'd be very interested in helping you get that started. So to summarize and sort of wrap this up, It's important to use the right automation tool for the job so that you're not completely frustrated and you know what the limits are, you know what you can and cannot do with it. Start anticipating which automation tools are going to be the most useful for you to learn in the upcoming years, the things that you're actually going to be able to take advantage of and learn them now. So that when you get to the point where you have to decide whether or not to automate, you don't have to stop and learn something. When you create something, especially a program or a script, even if you don't think it's very impressive, share it anyway. You'd be surprised how many people will be able to take advantage of it. And finally, know your limits, but stretch them and grow. Don't try to do this all overnight. It's a lot of stuff. But start somewhere and push yourself to grow. So during this presentation, we've gone through all the different stages of research, how to automate collecting, storing, and processing and analyzing your data, and then sharing it with the community. Any questions?